Vibe coding allows you to build functional software using natural language descriptions, bypassing the need to write manual code. Moving this capability onto a smartphone means you can capture ideas the exact moment they occur, rather than waiting until you're back at a desk. Whether you're out for a walk or riding the bus, you can use your device's microphone to give an AI agent its initial instructions. This approach to AI-driven development has been gaining significant traction among software creators who want more flexible tools. Because software concepts rarely strike while you're sitting perfectly still in front of a monitor, mobile platforms are the next step for these autonomous creation tools. But as this trend accelerated, Apple introduced a rigid regulatory blockade against mobile vibe coding apps. The company began blocking updates and temporarily removing several high-profile tools, including Replit, Vibecode, and anything from its ecosystem. Despite this aggressive purge, a startup named Lovable successfully launched its own functioning vibe coding app on iOS and Android in late April 2026. To understand how Lovable survived Apple's strict environment when so many competitors were blocked, we have to look at the mechanics of the ban itself. Apple's restrictions were not aimed at the concept of vibe coding or AI generation itself. The issue comes down to a specific developer guideline. Apple explicitly forbids applications from downloading unvetted code that changes how the host app actually functions. When an AI autonomously writes and executes new code directly on a user's device, it creates a security vulnerability. This bypasses the protective vetting process of Apple's app review team, since they cannot evaluate code that hasn't been written yet. A native application that operates as a container for constantly shifting, self-generated programs is incompatible with the security model of a closed ecosystem. Vibe coding startups had to re-engineer their technical architecture to stay viable on mobile platforms. Lovable's solution was to stop running the AI-generated software natively inside their own app. Instead, the Lovable mobile app functions strictly as a command center, designed only to capture and transmit your text or voice prompts. Once you hit send, the AI agent takes over, running on Lovable's backend servers. When the build is complete, it sends a push notification back to your phone. The workaround happens at the delivery stage. Instead of previewing the code inside the Lovable app, the finished product is outputted as a working web app inside a standard mobile browser. By pushing the execution to the browser, the core functionality of the native Lovable app never changes, keeping it compliant with Apple's rules. By moving away from native execution, Lovable bypassed the platform's security block while preserving the utility of building software on the go. Shifting app previews to the web browser was a practical compromise that kept these tools accessible. This approach allows users to start a project on their phone and immediately pick up where they left off on a desktop computer. Lovable's launch shows that AI development tools can adapt to the rigid infrastructure of established mobile platforms. This browser-based pivot means that being away from a computer is no longer a hard limit for testing new software ideas. By finding a way around these regulatory hurdles, developers can now use AI to build and review software from anywhere in the world.